Hello, welcome back and welcome to LNB. So in the last section, what we have done is, you can just see here, we understood what is the Docker architecture and containers, okay? Basically some images and creating container from there, okay? So practically we are going to understand what is your container, that and how can you start it and how can you execute some programming language code by C language, okay? So when it comes to container, you know that from the last discussion, whenever we create a container, we need a Docker image. Okay, so Docker image that we can download from any registry like Docker Hub. And if you talk about images are read-only templates. That means all the instructions that you want to use, that will be read-only, and by using those images you can create container. Okay, if you want to make any changes, that changes will be always in container, not in Docker image. For example, let's say you have operating system image, so you don't have to write data in the image. You install that image as a form of OS, then you do tasks in the operating system. Okay, so how I'm going to create my first container in a very microsecond, you can check right here. So I'm opening my terminal, and here let me check that do I have any Docker image or not. In the last session we have downloaded some images like Alpine, BusyBox and all. So as of now, this is my MacBook and I want to create a container with some program. Okay, so what I'll do, I'll use Docker run instruction. Okay, run instruction means always a new container, means whenever I do Docker run, that means a brand new container. I can name my container like Ashutosh container 1. Also, I have to be interactive. If I want to interact with a shell of container, the name of my image and what program I want to run. Okay, but this time I'm using shell because I want to do some exercise inside the container. So it will take very few seconds, and that's it. So I got one container. You can check here. The container has the kernel Linux, it has kernel version this one, and the operating system of container is Alpine Linux. Okay, I can do number of things like checking IP address and many more things like that. So container has its own file system. This has its own IP address, its own OS, and one shared kernel. If I want to exit out from the kernel, from the container, sorry, I can do exit. Okay, so when I do exit, my container is not in running state. That I can check by Docker ps. But if I want to check the container that is in non-running state, I can use -a, and here you can check the container is in exit state. So a container has a lot of information like container ID, the image name, the program I given, and the name of container. So if I want to start the same container, I can do start like this, and now my container will be running. Okay, so container will be having one parent process, and that parent process will be by the one that time we given during container creation time. So if you see by Docker ps again, container will have the same parent process, and you cannot change that parent process in the container. Okay, if you want to go in that running container, you can use docker exec followed by container name and the command you want to run, like cal, like date, or you want to go inside, you can use cell. I'm again here. Okay, I can create some directory, some folder, I can go exit, and this time if I do exit, it's not going to stop my container, because when the container is started and you are running inside that container like exec, then the container is not going to stop. Anyway, so that is your first container you can create. We have little more deep dive in near future about container command line, but for right now you can use this method. Okay, what is the next thing I want to do? Because I haven't created any a kind of container for any particular purpose. So what I'm going to do, let's say you have your programming language code like C. and you want to run that program in a container. Why? Because generally you use your Windows or Linux and install your platform, and then where you write the code, compile and run. If the same thing you want to do with the container as well, so here I'm having this number of code. Let's say I'm going to use while.c, and this is an infinite while loop. Okay, I'll be using this code and I want to run in container. But the point is, if you want to do that, then you have to understand one analogy. What is that? So let's say you have seen that container can be created from image. Okay, so if I do this thing, and here I have this image, and from this image I'm creating container. Okay, so right there, this is my image, this is my image. Which image? Docker image. And from this image I want to create container, and the instruction I'll be passing is run. But the point is, as a developer, I have my code like while.c. How this code I can transfer into the container? So you can do that by normal copy, but the point is, every time you create a new container, you have to copy that code. So what is the standard practice of running a code into container? So here I'm gonna introduce a new word called containerization. And what exactly containerization meaning? That means, let's say you have some program, so you have to convert this program into Docker image, and when you convert this program into Docker image, then from this Docker image you can create container. Because in Docker image the program will be always fixed, persistently will be there. Okay, so for this purpose, if I have some program, some database, some application, some web app, anything, right, and I want to convert into a Docker image, so that from that image I can create container. Okay, so for this purpose I have to use some technique, and that technique is Dockerfile. Okay, so what is Dockerfile? Dockerfile is a set of instructions that you can write and you can integrate with your code. Then you pass a build instruction to your Docker engine. So what build instruction will be doing? It will use your code and Docker file to convert into Docker image. Now you know, if you have Docker image, you can create a container by using run instruction. Okay, so what I'm going to do is, just to give you that idea, I am going to create one empty directory. Let's call it lnb code. Okay, and under this I am going to take this code that I have already written. So to my git URL, I can just clone it by git clone, and here like this. Okay, so here I can go in clang directory, and I can say I have number of code. Okay, so let me introduce Dockerfile here. Okay, if I introduce Dockerfile, then I have to integrate with my code. So simply I'm introducing a file called Dockerfile. The file name of Dockerfile must be Dockerfile initially, and here how and what I'm going to write inside Dockerfile. So let me write it first, then I'll be explaining later on. So from CentOS maintainer, my email address, it's double H by the way, and I'm creating a directory called /code, and inside that code I want to copy while.c to code directory by the same name. By default in CentOS Linux, the GCC compiler is not there, so I can install GCC compiler first. Okay, then I can go to directory under slash code, then I can compile it by GCC of while.c. This compilation process will give me that output, and the output I can run by using dot slash a dot out. So don't worry, I'll be explaining this later on in next section, but right now, yeah, this thing. I'm saving this file, and what this Docker file is doing, I'll be explaining that. So let's say I have this Docker file. What I have to do, I have to send a build instruction against my Docker image. So if you check here, Docker images, I have few images, and the image having two things, a repository and tag. Okay, so now Docker build, I want to build what I want to build the image. I need to give -t tag, some repository name, let's say lnb column. In tag I can give anything, let's say c lang. Okay, and dot means the location where your Docker file is present. So it's going to build this entire process. So what is happening, first it will connect to Docker Hub, download the CentOS image, and from that image it will take that data and do all the installation that I have written in the Docker file. So this process may take a little bit time, but Docker engine is already aware of all these instructions. So let's wait for that, and when we'll be done with the installation part, then automatically it will do the next step like compilation and that thing. So we'll be I'm just making this video fast forward maybe if it is taking more time. And yes, finally I got this. So if I do Docker images, I have this image. Okay, so you can see from the above diagram, now I created my own Docker image that has my C language code. Okay, so from this image, if I want to create container, so how do I do? Docker run. Okay, hyphen name, let's say lnb container1. Okay, -it and the -d. What is the meaning of -d? It will put the output of program in the background. And it means interactive container, and the name of image. I don't have to supply anything in the last because my Docker file already have that cmd instruction. That means this will be my default container process. Okay, enter. If I check that by Docker ps, I have this default container process, and I want to check the output, then I can check by docker logs -f and this one. See, so basically it is printing me hello world like this. Whatever code I had, it is printing like that. So this one. So this container will be running forever till the time the program is not exiting. Okay, so in this particular thing, what we have seen, we have a code, let's say while.c, and I don't want to install C language platform in my Mac, Linux or Windows. So what I did, I write a Docker file, and let's say this is my Docker file. If I explain a little bit like here, so I'm saying to my Docker engine that use or pull CentOS image from Docker Hub. Okay, this maintainer is information about myself that you can ignore. It's an optional field. Okay, so if I pull the CentOS image, I need to copy that code that is present in my system. So what is run instruction? Run instruction for running anything inside CentOS container. So anything you write under run instruction, so what is going to happen? From CentOS image, a container will be created and this program will be running. So, and now, but this is inside container. But my data that I want to copy inside container directory, so I need to use this. So from host to container data copy. Okay, so we have data where we have data in this directory, and this data I want to copy in my container, so I'll use copy instruction. Okay, I copied it, but to compile that code while.c, I don't have compiler. So again, it will install gcc inside container, right? Then I'm going there. It's like changing directory, and here I am compiling inside container, because run means anything you write it will be doing inside container. I already have copied this while.c. Now finally cmd is for default container process. So if you create container from this image, what will be the default process? That will be this. So what is a.out? Who have not run C programming language in Linux, for them I can give you this hint. When I do gcc while.c to compile, it will create a compiled file called a.out. And that a.out I'm running like that. So this is a small introduction about this. Okay, so finally what you can see here, we have created our first container by integrating our C language code. Okay, so that's it from this lecture. We'll be letting you know the extra information about that. So see you in the next lecture. Thank you so much.